Well, hello there. Good morning, good afternoon, and good evening to everybody joining us today. In just a minute or two, we're going to get started, but first, I wanted to cover some housekeeping items for today's webinar. Everybody joining today on the webinar has been muted, so if you do have a question, just go ahead and ask it in the question window of the GoToWebinar screen in front of you. We'll try to get to every question, either individually or grouped together during the Q&A session at the end of this presentation. Once the webinar begins, sometimes people have issues seeing the slides advance. So if you see that and it happens to you, just close the webinar and then rejoin, and that usually fixes things. We are recording today's session and we'll share the link with you after the webinar. It usually takes a few days for it to be available and posted to YouTube, but we'll let you know on social once it's up. So now we're about ready to get started with today's session. So today's session, I'm really happy to be talking about Einstein again today. And the topic of today's webinar is building smarter apps with Einstein Object Detection. So my name is Arabella David. Today I'm Canadian, so it's Arabella David A. And I'm joined today by everybody's favorite green-haired German, Renee Winkelmeyer, who's calling in from Germany today. So thank you for joining us and good evening to you. And we're also happy to be joined today by Zineb Laraki. So I don't know if people were joining the Einstein AMA, the Ask Me Anything session we had a couple of weeks ago, but we had a moment where we lost Zineb completely in the call. And I don't know if you know this, but she was calling in from Morocco. So we found her, we brought her back to HQ here in San Francisco, Salesforce headquarters, and we're really happy to have her here again today as Einstein Senior Product Manager, here to talk to us about Einstein Object Detection. So if we, before we get started, this is not a Salesforce presentation unless we have our Salesforce forward-looking statement. So do bear in mind that if you do make purchasing decisions, please make your purchasing decisions based on what's generally available. And we assume no obligation if you make purchasing decisions based on these forward-looking statements. So if you want to read this further, feel free to check this out by hitting pause on the streaming video once we go live. But let's give more time to Zineb and Renee. And if you do have questions, or if you want to follow up with us, or just, compliment people on their amazing slides or whatnot, feel free to reach out to us on all the socials. So we've got Twitter, Facebook, LinkedIn, and YouTube. So it's all Salesforce developers. We are Salesforce Developer City here. And let's get started. Bear in mind, we do have that Q&A at the end, but I really want to kick it off and hand it off to Zineb and Renee. So off you go. Let's talk about Einstein.
Awesome, great, thank you. So just to kind of give everyone an agenda about what we'll be doing today, we'll talk about Einstein Platform Services generally and just kind of give you guys an overview to make sure, level set everyone here. Then we'll talk specifically about Einstein Vision. Then Renee will walk us through some really cool demos, and then we'll answer questions at the end. So as you guys are aware at this point, AI has boosted our personal productivity, right? We, as consumers, expect a certain, our applications to be smart in some sense, right? Whether it's Spotify customizing our playlists, or Facebook helping us tag our friends, or, smart routing, giving us ETAs. We have been very fortunate to have AI help us in our personal lives. Now, the great thing is that AI can make us more productive workers too. And Salesforce is really excited about this and really looking to see how can we help, salespeople sell faster? How can we help customers have delightful experiences? So, how do we make workers productive? How do we make customers have their customers experience delightful? So with that, Salesforce has introduced Einstein. And so Einstein makes CRM the smartest CRM. We have several features that are GA across our clouds, and we have some that are in pilot. And so this is just kind of a list of a few different services or products that we have available that leverage AI. Now, a lot of these services that we saw on the previous slide deal with structured data. So when we talk about structured data, we mean, typical CRM data, tables, logs, things of that nature. Now, what we're also noticing is that there's an explosion in unstructured data as well, right? So when we're talking about image, voice, text, and until recently, a lot of these types of unstructured data were not leveraged or able to be analyzed and get data out of them. Now, the great thing is that with deep learning, we can start gathering and understanding patterns in these more complex data types and derive insights from that. So for structured data, we can use traditional machine learning. For unstructured data, so when we're talking about voice, image, or text, you really need to use deep learning. So at a very high level, what is deep learning? So it's loosely based off of how the brain works, where you have nodes or weighted connections, and information is passed on from one layer to the next. And really, what you provide these networks with is a bunch of sample inputs and sample outputs, and it's able to learn from these examples and understand patterns from these examples. And then when given a new input it's never seen before, it's able to predict the expected outputs. So kind of to draw a parallel here, you can think about how a child, when a child is learning about the world, you don't tell them, when they're learning about like cats, for example, right? You don't tell them that, it's a furry animal with 4 legs and a tail, etc. What you usually do is you show it a bunch of examples of cats, and you're like, there's a cat, and eventually, kids are able to say, okay, that's a cat, even when it's a new cat they've never seen before. And so that's loosely how, deep learning models work. And this is great because we're now able to, get data and get insights from data sources that we couldn't before. And so, businesses want to make their applications smarter and leverage these new types of data, but the reality is that this has traditionally been very hard, right? You need a team of experts to be able to build these models. You need specialized infrastructure to be able to deploy these models. You need to be able to keep up with your scalability needs. The space is also continually evolving, so you need to keep up with that. So it hasn't been easy for businesses to implement or embed this intelligence into their application. Now, the great thing is that Salesforce is really democratizing deep learning, and we're really providing this as a managed service. So how do we do that? Well, first of all, it's a hosted infrastructure. So we make it very easy for customers to upload their data set, train their models, understand how their models are doing, as well as meet their scalability needs. We take care of all of that, get predictions in real time. So it's really taking away all of this complexity and really providing this as a managed service. The second thing is we've built it for Salesforce. So our deep learning architectures are for CRM data, for CRM use cases, and it's built on the trusted Salesforce platform. And then the other great thing is that we work very closely with the Salesforce research team. So half my team is actually the Salesforce research team that's advancing the state of the art in computer vision, NLP, and voice. And so we're able to leverage their breakthroughs and the advances in this space and work very closely with them and close that gap between the latest advances and taking products to market. And so that's one of the big advantages that we have. And so with that, we've introduced two categories or families of products. We have Einstein Language and Einstein Vision. Under Einstein Language, we have sentiment and intent. And then under Vision, we have object detection and image classification. All of these services are GA. And today, we're going to talk specifically about the Einstein Vision products. So what is Einstein Image Classification? So Einstein Image Classification is our first computer vision service that Salesforce launched. And really what it does is it makes it very, very easy for customers to build custom models that fit their use case. So with that, it's you simply, decide what you want your model to do. So let's say in this picture, you see that we wanted a model to recognize whether a picture was of a 2-door refrigerator versus a 1-door refrigerator. And so all I'd have to do is simply put images in a folder, zip them, upload them, and then train a model and understand how that model is working. And once I've done that, I'm able to integrate it into Salesforce applications, Salesforce workflows, or external applications. Now, we're seeing customers use Einstein image classification across a lot of use cases. So we're seeing it being used for visual search. So expanding the way customers are discovering or finding your products to increase sales, for example. We're seeing customers use it for brand detection, so monitoring of social media, as well as product identification, so streamlining sales or service processes with that added ability to recognize your products and images. And the great thing is we're also seeing not only a variety in use cases, but also a breadth of industries. So we're seeing everything from visual auditing in transportation, product identification for CPG, we're seeing visual search in retail, or even the healthcare space. And so it's really exciting to see all the different types of problems that can now be solved with this new functionality. With that, we also came up the need to launch Einstein Object Detection. And so Einstein Object Detection is more advanced computer vision functionality that allows you to not only categorize an image, it is able to locate exactly where objects are in an image. And so with that, you're able to do counts, determine the size of objects in an image. Once again, we've made this very easy for you to build your custom models. So to build models to recognize the objects that you're interested in. And then once again, you'll see that it's very easy to integrate these models into your Salesforce workflows or external applications. Now, specifically for object detection, I'll give you a few use cases here. In the CPG world, we're seeing customers use object detection for on-shelf availability, share of shelf, as well as planogram compliance. Now, just to take a second here to kind of go a little deeper to explain the different networks that we use. So for different types of problems, we use different types of neural nets. Now for computer vision, we use what's called a convolutional neural network. And really what that means is that the network is rebuilding the image from the ground up to be able to understand what's in the image. So it first looks at the pixels, and then that information is passed on to the next layer, which understands edges. Then from that, you understand object parts. And then from that, you understand objects. Now, this is just kind of for your own personal knowledge. The reality is we've abstracted all of this complexity. And really all that customers have to do to build their custom models is, define your use case and decide what you want your model to do, and collect images. So collect images that you would want your model to recognize the objects in. Then the second step is labeling, which in the case of object detection, it means drawing boxes or providing the coordinates of exactly where objects are in the image. And there's tools available to help you do this, both open source tools as well as crowdsourcing tools that can, that can help you. This can be a very manual step, so you can outsource part of this labeling process. So once the labeling is done, you basically zip all the pictures and this, CSV basically with the coordinates, and you upload it using our APIs, or as Renee will show you, using our Lightning components. Then you make another call to train your model, and at that point, you get a model ID. And with this model ID, you can do two really cool things. One is you can start getting predictions on new images that the model has never seen before, which is great. The other thing is you get model metrics. And so you're able to understand which of your objects the model is able to detect very well versus not. And so there's a step of iteration here that you have to go through, right? Of really like understanding, well, maybe I need to provide more images, or maybe I need to do some relabeling to really improve the results from your model, right? Or you might say, like, this is good enough for my use case. So once you're happy with your model, you then integrate it into any application. And as I mentioned, these can be Salesforce applications or external applications. And so with that, I think Renee is going to walk us through how, show us each of these steps and how you can build your own custom model.
Okay, cool. So welcome everybody. First, today I'm not in Germany, I'm in the London office, so I hope the Wi-Fi holds for the webcast. And what you see here on the screen is what I call the Einstein Playground. This is an open source project that allows you to use any of the Einstein platform services in any Salesforce org without writing any line of code, right? So you can declaratively build all the things that Zineb explained, like upload the data set, train a model, and so forth, just do with this open source project. But let me take you first through a couple of those things that are relevant to any of the Einstein platform services, and in this case, for object detection. So when Zineb talked about that you have to collect your data, right? And we did this for the example too. You have to go through a couple of iterations and to collect lots of examples, like in this case, serial boxes for your image data. Zineb may correct me, but I think for object detection, it's 50 minimum per object that the Einstein platform needs for a good training. The more is better for sure. As you can see, we have many variations of those serial boxes. So this is the very first step, collecting your data. Then for object detection, it is also important to specify the location and the height and width of each object within the image. So basically, like drawing a box, a bounding box around every object. Once you did this, you will have to create an annotation CSV, and this is just really big. So I'm just showing you the first one. And this is also part of the data collection process, which can be really manual. First, you have to specify the image name, and then you have to specify for every object within that image, height, width, as well as the X and Y coordinates of the top left corner of that object. And also you have to specify a label so that Einstein platform service knows what is the object that I'm currently detecting. Once you collected all the data and zipped it, as Zineb explained, you can use either the APIs directly, and we'll see them at the end of the presentation, but you can also use the playground directly with the data creation tab in here and just upload either from an URL or drop a file in here. I highly recommend using the URL option because depending on how many images you upload, it just makes sense to, for example, store that on AWS. So once you have created your data set, you will go to the data set section, and your uploaded data set will be here visible. And as you can see, I have here now 3 labels in this data set for 3 different cereal boxes: oat cereal, cornflakes, and brand cereal. And you also see the number of examples that we used for this demonstration as a training. Once you uploaded all this, you would create a training, and the output of this is a model. And this is really important, as you will see it in a later demonstration. Once the model is trained, and as you can see here, hopefully succeeded, you will get a model ID. And this model ID is then used in the later prediction steps to run the actual prediction, which means you can have many different models because you likely went through many iterations to refine your data set. So again, you create your data set, you upload it, you run a training that will return you a model ID. And once you get that, you will run a prediction. The really neat thing with the playground is that you can just do it with, again, writing any line of code, right? And I'm already seeing here my custom Alpine model that I uploaded, and I will now upload a local file. I just take one of those example images in here. This will now run the prediction process, and in a couple of seconds, we should see the result, which is in this case the identification of two different boxes. So with this information, I know now, based on the object detection pattern, that I have from each label 2 boxes within this image. And you see those nice frames around this. I used a small JavaScript library just to highlight that, so that you have, maybe also for your users, a visual representation. When we switch to the raw output, and this is basically the JSON that gets returned from the Einstein Platform Service, you get an array of probabilities. That means for every object within that image, you get A, the label, so that you can identify what has been detected. You get a probability value, which is a float, right? So this is 99.1%. And you get also a bounding box, which represents the outer X and Y coordinates of that object. And with these information, you can, as you can see in the image, identify the location of an object. You can specify which object, and you can specify the count of objects. So then I've had this really nice use case for the CPG industry. And you can use, for example, the Einstein Platform Service in a mobile app. So here I have my real iPhone. I'm opening Salesforce 1. And yes, I'm enjoying Salesforce for sure. And I have a small Lightning component, which I called Shelf Scanner. So this could be an example, a Lightning component that folks that work in a local store use every day, or in Community Cloud. So when I upload file, and I'm now using my photo library because I don't have those boxes here with me, I'm now running the prediction just from my mobile phone. And I'm getting, again, different values. Don't wonder about the color over here, but you can see in the titles, because I'm using just a different setup, that the 3 different brands have been identified. And as an employee, I can now hit submit, which then would save the results of the shelf scan within my org. So when I go to my scan results, I can now see that I have scanned products with a count of 1 and associated with a shelf scan. So based on an object detection that I ran from my mobile phone, you can, for example, then run a process builder flow within your org, for example, to restock a shelf or restock a store based on different scans. Another thing that I want to highlight in here is that this service is not built into the Salesforce core platform. And this really allows you to use it from anywhere because it is just a REST API. So what you see over here is Postman. And I think many of you are familiar with this tool for testing APIs. And by issuing, for example, a simple get datasets request, which gives me a list of all vision-related datasets, you're getting the full JSON response just from our local machine. And this empowers you to use this service or any of the Einstein platform services from within any kind of application, be it your Salesforce org, be it an on-premises Java application, be it an iOS application or an Android application. You can just leverage the capabilities from any kind of application development platform. And you also don't need to implement a lot of code for this, or you don't have to implement all the data sets mechanisms on any platform. So for example, when I go back to my Salesforce org, and you remember the iOS app that I showed, when I go to Setup, and I'm in Lightning App Builder, I have a really small Lightning component that is used on the mobile phone on the Salesforce app. And as you can see here, I'm using the design component parameter in the Lightning component to just pass the model ID to this component. So you have declarative capabilities for mobile, or for an example, direct in your Salesforce org. And your app builders don't have to write any code for this. If you want to get hands-on, and I highly, highly recommend this with any of the Einstein platform services, you will find the playground, including Apex wrappers, so really complete Apex library here on GitHub, and I think Arabella will also post that at the end, or at the landing page of the webinar, and as well as the shelf scanner, which is also an open source project, which you can directly put into any org and play with it. Zineb, think.
Awesome, thank you, Renee. So just to wrap up here, thank you. So as Renee showed, these are simple REST APIs that you can use to build custom models, and we have also UI or Einstein or Lightning components that you can leverage to train your own models, and then integrate these models into your workflows. Now, we also have different clouds at Salesforce that are leveraging these exact same APIs. So Einstein Vision for Social Studios leverages our image classification as well as object detection. Einstein Language for community sentiments is leveraging our sentiment APIs. And then there's Einstein Language for Einstein agents. We also have field service, Einstein Vision for field service, that are using it to streamline field service processes such as understanding parts and reordering, automating some of those steps as well. And if you don't mind going to the next slide, Renee. The great thing is that you can do this too, right? So you can now build smarter apps with these Einstein platform services. And so you can embed, we talked specifically about image recognition, but we also have our NLP or Einstein language APIs available. They work in a very similar manner. And so you can harness the power of unstructured data easily into your applications. And you can customize these for your businesses. We have some pre-trained models that might serve for some CRM use cases, but our big differentiator here is that we make it very easy for you to train your own custom models and embed them into your Salesforce or external application workflows. Here we just have a few different additional examples, everything from augmenting lead scoring with image data. So we're looking at, for example, if you're a solar company using, maps to augment your, if you have the, the location, the home address of a customer, you can augment your data, your lead scoring with image classification, intelligent case routing, identifying your brand on social media or on different channels. So there's really a wide variety of use cases that you can leverage these functionalities for, and we're excited to see what you guys come up with. And so with that, if you don't mind going to the next slide, I think Arabella's gonna.
Yeah, so I've been seeing the questions coming in, so thank you for asking questions, and we will get to them in just a second. But before that, we've got questions for you. So a little bit of tradesies going on here. So before we kind of give up our information about Einstein and Einstein Object Detection, we want to know how we can make these webinars better for you. So we've had some kind of specific questions regarding like content that you guys want in the future. We'd love more of that. If you have any specific feedback, whether it's good or if it's bad, let us know what you want to see more of, and let us know what we should stop doing. So with that said, if we go to the next slide, we can then jump into the questions. So thank you all for everyone who's submitted questions into the chat window here on GoToWebinar. So let's dive in. We've got a lot of time for questions here. I'm glad to see so many questions, especially considering we just had that AMA, that Ask Me Anything, a couple of weeks ago.
We intentionally wanted to keep it light on the slides and really kind of address your guys' questions on these services. So,
yeah, for sure. So the first one we have here is a really interesting one. So it's about, can I do any certifications specifically on Einstein?
Renee, do you want to take that one?
Certification, I think that's.
I can go ahead.
Yeah, sure. Yeah, yours.
Oh, so if you go to certification.salesforce.com/developer overview, you can see the menu that we have available for what you can certify against. And if you want to build smarter apps using Einstein, it's going to be a component of our certified platform developer program. So just explore there on the site. There's a few different levels. There's levels 1 and 2. And another thing is if you want to get more kind of hands-on with Einstein, we'll also be having some content and material that'll be super interactive for everybody at the upcoming Trailhead DX conference we have here in San Francisco in late March. So I hope that answers your question. We do know that there's a lot of demand specifically for this, and as soon as we can kind of tear away Zineb and Michael from this, we can kind of have them help us build out like a more formal certification program with the team. All right, so I hope that answers your question, and we'll jump into the next one here. It's related to it. So there's a lot of curiosity in kind of the overview of Einstein. So this question is there a presentation that provides all capabilities of Salesforce Einstein as a whole? It's at times difficult to wrap my head around this, and it would be really beneficial to see all of the capabilities explained in one single presentation.
So actually just this morning, I got an updated first call deck that has an overview of the different Einstein functionality across all of our different clouds. So maybe I'll share that with you, Arbella, and then we can share it with the team.
We can share a piece. Let's check on that one.
Yeah, okay.
Yeah, we can definitely use parts of it.
Yeah.
On the site here.
Perfect.
So yeah, we'll put extra forward-looking statements in it.
Of course, yeah. As always.
Yep. But I think that goes into our next question here. And this is a question that we always have for any feature that we make available for developers. Because you want to get more fluent with it, you want to learn how to be really efficient with it. But does it cost money to get started with Salesforce Einstein?
So I'll answer specifically for Salesforce Einstein Platform Services, which are what we talked about today. So both for Einstein Vision as well as Einstein Language. You can sign up for free on Einstein.ai, and you get 2,000 free predictions per month. So these are predictions. So that's when you have your model predict, classify an image, for example, or detect objects in an image, or classify text, right? So when it predicts something, that counts as a prediction. So you can, uploading, training models does not count towards that. So once you've used up your 2,000 predictions per month, then it becomes a paid service, and you can talk to your AE. You can purchase both through Salesforce or Heroku. And I think there's a later question about the exact pricing. It's $4,000 per month for 1 million predictions per month, and that's available. All of these services are GA right now.
That's a lot of predictions.
Yep.
It's a lot to go through there. Great, thank you for that. So just to summarize, for 4,000 for a million?
4,000 per month for a million.
Okay, per month. There you go. So our next question here is, I'd love to hear some thoughts on the use of image recognition in engineering applications. So the specific use case here is, for example, detecting damage on machine parts. That's a really interesting use case. Have you guys thought about that?
Yeah, so I kind of alluded to this a little bit earlier. Field service is actually looking to integrate Einstein Vision into their field service application for a very similar use case, which is, when the field reps are out in the field, and sometimes, parts are hard to recognize. You don't know the exact, name of these different parts. So, or, you're new on the job, or whatever the case may be, you'd be able to simply take a picture of the part and have the part, automatically recognized, and then streamline that to whether it's like reordering or replacing the part, whatever the case may be.
So to summarize, as long as you train up your models properly, it's no problem at all, or?
Yeah, so, depends on the use case here, but we are seeing customers use it to understand different parts in the engineering world or mechanical world.
The
machine world.
The physical engineering world,
yeah, exactly.
as opposed to the software engineering world.
Yeah.
Yep, let's make that distinction here. Great, thank you. So here we go. The next question is also a super interesting use case question. So can the image recognition determine the sizes of a room if it has a reference object for size, like if you just put a banana in there for scale?
So what object detection returns is an XY coordinates and heights and width. So you get basically a box of where the object is in the image. Now, if you have a reference object, so let's say I train a model on understanding like a specific, water bottle, right? And also I train it on recognizing different tables. If I have the specific water bottle in the image, it will give me the size of that image the size of the object in that image, as well as the size of the table in the image. And from there, you can simply do some computation to kind of translate it to actual measurements. Was that clear enough, or do you feel like?
I think that's pretty interesting.
Cool.
Renee, have you heard of this before, or do you have any further thoughts on this?
I think it's a really interesting case, and that was in it. That is, just the only and right approach, because it just depends on what you can relate to, right? So you have to have a reference, as the customer asked, and based on that, you could definitely do that.
I recommend as reference objects a Astro plushie.
They are rare. They are really rare.
Yep. Great, thank you both. So this next question is, I think it's interesting because it's asking about, what about video files? Isn't that just a bunch of still images, right?
Exactly. So this question comes up once in a while. The reality is, for every use case that we've encountered so far, it can be solved by making these the video still images and then analyzing the images. So yeah, so there's even like a demo available that somebody built that uses computer vision or object detection for a Lego cart to move around, right? And so it's using a video, quote unquote, as a stream input for that.
Oh, wow. Wait, okay, tell me more about that. That sounds really, really cool.
It's just, they built a demo track and they used object detection to make sure that this moving Lego vehicle stays on the track.
Okay. Is there a blog post about it, or is it like a YouTube video?
Renee, do you know which demo I'm talking about?
Yes, I think it was a girl from Australia.
Okay. Yeah, let's try to dig it up so we can share it out with people afterwards.
Yes.
Okay. Nice. So long story short, yes, video files.
No, long story short is no video files, but you can.
But you can make still images from the video files and work from that.
Exactly.
Okay.
And for most things that works.
As long as you slice and dice your video.
Yeah.
Okay. And use Lego.
Lego's not necessary.
I'm saying Lego's required.
Always Legos.
Okay, cool. So the next question we have here is best practices for labeling images and object detection. Do we have specific Trailhead modules on object detection? And I think this is something we were just chatting about. There is definitely a project on Einstein Vision.
Yeah, so there's Einstein Vision. There's not a Trailhead specifically for object detection, even though, once you're familiar with how our APIs work, it's very similar. There's a trail for image classification, which I definitely recommend. The added step, as the person referred to in this question, is the labeling part. So there's two things I'm going to say here. One is we do have a getting started guide that I'll share, that we can share on social media as well, that has different options that you can leverage for labeling. So there is, you can use crowdsourcing, and we've been using a partner that can help with that. So you can crowdsource your labeling. They take care of all of that for you. We also have an SI that's built basically a component that you can install into your org to make labeling easier.
Does everybody know what an SI is?
System integrator. And so they have a Lightning component that you can purchase that they've created a tool specifically to do the labeling for object detection.
They can find that in App Exchange, right?
They can find that on App Exchange. And then also there are open source tools that can be used. So there's a lot of options. It sounds more daunting than it is. I think both the data collection part and the labeling part is just about, getting started to some extent, right? So the data collection, just go out there and do it really, or start collecting the images. And then for the labeling, find somebody in-house to do it, or crowdsource it really.
Okay, great, thank you. Just get it done. Once the model, this next question here is also about labeling. So once our model labeling is done, how do we train our model? Which technology is used?
Okay, so once you've labeled the data, so you label the data, not the model. So you collect images, then you basically label the images, which means providing the coordinates of the objects you want in those images. Once that's done, you just zip all of those things together and you upload them to our service. Now, to upload them, you can use different things. You can use our APIs. These are REST APIs that are easy to use. Or as Renee showed, you can use, there's an Apex wrapper that he's built that you can leverage, and basically it becomes a Lightning component that you can just click through all of these steps. But you just basically upload the data sets, then you need to make another call to train, or in the Lightning component, you click a button, and the model's trained for you. And you don't have to worry about anything else. We provide you model metrics so that you understand how the model is performing. And our documentation does a very good job at explaining what each of these model metrics mean. You don't need a data science background to understand these things. We kind of walk you through how to leverage these model metrics to improve your model before you integrate it into your application and start using it in production. And it is an iterative process. I think that's kind of the shift that you need to kind of realize is like the first model that you're going to create is not likely going to be perfect, right? And so there is an iteration step that you need to take into account there.
Okay, great, thank you. So this is a very practical question, I think, that we have here next. So if the object in the image is not oriented the same as the uploaded image, does Einstein do rotation automatically? Or do people need to load the same images with different rotations?
So we don't do any rotations. So that's something that you would have to handle.
Okay, there's another step to scrub through. Here's another interesting use case question. So let's see what both of you think of this one. So are there people who can use object detection to classify faces? So that's an interesting question for a lot of reasons, but are there any performance challenges?
So you can use object detection to train a model, for example, on emotions on people's faces.
Really?
Yeah.
Okay.
So if somebody is, happy, sad, angry, etc., right? But in terms of, facial recognition, there's definitely, there's facial recognition services that you can use for that. Definitely would not be getting, the results that you would want. For object detection, you also need to provide, for each object or thing that you want recognized, you need to provide a lot of examples as well. So you need to think about that.
Right.
Even in the emotion use case that I gave, you want to make sure that you provide a range of examples. So you want to make sure that there's young people and old people, people of different races and things like that. So it's not like, if you give it examples of only, young, happy people and all the sad people are old, then it's just going to see an old person and it's going to think it's sad, right? And you need to be careful about these biases that you can put into your data. And so, just need to think through some of these things.
Yeah,
and how you,
that's crazy. That's a lot that you need to kind of process, especially when you're training these models. So
exactly, it's important to make sure that the data that you're providing,
is unbiased.
Covers, exactly, covers the range of use cases that you want.
Right. Renee, do you have any other thoughts on this one?
Yes. So expected, right? so a possible use case, and I used that recently for a doorbell, could be using image classification. So the question is, do you want to really detect an object within an image, or do you want to identify a pattern in an image, right? So if I have 50 images of my best friend and he rings the doorbell and the camera takes a picture of him, that would be able to identify him using image classification because he looks really unique anyway. And object detection would be just the wrong technology. So depending on your use case, you already should make a decision if is object detection the right thing. So do you want to detect objects and sizes and counts and positions of an object, or do you want to just know is it a specific kind of image or is something specific in it?
Yeah, that's a whole dimension. I think that I like the answers between the two of you, because it's really kind of beginning to approach the dimensions of what you need to think about when considering recognizing faces using Einstein Object Detection. So thank you both for that. Let's see here. So the next one we have here is about location settings. So do all of the object location settings have to be manually created? Are there any tools available that process the image and provides the data?
So I can take that. So there are a couple of tools available that allow you to upload the image. At the end, there is a manual process where you have to define what object you want to have within that image, or which object. So you have to do that. But there are a couple of JavaScript libraries available, or also I saw 2 Mac applications where you can just do that, or you use any kind of image editing tool, for example. right? But you have to go through the manual at least.
Yeesh. We have another very practical question here. And Renee, maybe you can address this one. So when creating the JSON for the data training that includes the label, height, and width, does the height and width center on the object or the space of the object it takes up on the image? I hope that was clear.
It is based on the pixels. So you specify the height and the width based on the pixel size of the image. Right.
Okay.
So if your image is 4,000 to 4,000 and the object is within that 500 to 500, for example.
Okay. So there's a related question here. I don't know if this is the same person that asked this, but are there any UI clickable interfaces for creating a data set from images? So to clarify, where you can upload an image and then draw borders of the item in question and then export the data set for future use.
Yeah, that belongs to the question before that. So there are a couple of tools available or JavaScript libraries that you can use in your own web applications to achieve that.
Okay.
I think we can dig 2 or 3 of them out and provide them at the after the webinar for the Q&A session.
Okay.
Resource.
Yeah, sounds like we have a lot of resources to share out to all these curious people after this call. So we've only got a few more minutes, so we've only got time for a few more questions here. Do we have an Einstein API guide? I'm sure we do. Right?
Yeah, so if you go to Einstein.ai, you can both sign up as well as find a link to our documentation. Our doc writer is amazing, and our documentation is very easy to read through and kind of walks you step by step. We even have these quick start guides. So definitely a wonderful resource to kind of read through. So Einstein.ai.
Einstein.ai. That is catchy. Wonder how you guys came up with that.
Yeah. You also have a link to our research papers from there as well. So that's also if people are interested.
Oh wow, that sounds really in depth. So great. So another question here we have is, can Einstein training or retraining happen through code, whereby through API code, training images can be automatically trained?
Yeah.
I hope that was clear.
Yeah, so all of our services have an API called the feedback loop. And really what that allows you to do is basically, kind of as like a question is hinting at, improve your model as it's continually being used. So let's say, I created a model that recognizes back to 2-door versus 1-door refrigerators, and it's being used out in the real world for some, as it's being used, your service agent notices that one of the images was labeled wrong, and there's 2 doors, whereas in reality it's 1 door. You're able to, send that back via API to using the feedback loop and retrain your model with the correct label. And so what that allows you to do is that your model improves over time. And so the next time that it sees an image that's similar to that, it's able to correctly predict which category or label it belongs to.
Okay, great, thank you. Here's another question. So you had mentioned before that you can download some tools to make working with Einstein Object Detection easier by going into App Exchange. Can you share a little bit more detail about what you'd be looking for to find what helps developments on App Exchange?
So one specific SI that's built a tool is called Share and Fix. And so they basically built a Lightning component that you can integrate into your org. That's a great tool that allows you to just draw boxes on images, and they automatically create a CSV for you that you can include in your data set to train. And so they've kind of really streamlined this flow and worked closely with, they've built this specifically for our APIs.
Okay, great, thank you. So this last question here. Are there opportunities to join the Einstein team for folks with a background or interest in machine and deep learning?
Yeah, we are hiring. So definitely, check check online. We have some few spots available across our different teams. So yeah.
And I can say they're a fun group.
Yeah.
They're
feel
super
very
smart
lucky. Yeah.
and they're building smart stuff. So yeah, feel free
helping
to
people too, which I really like.
Yeah, totally. So do check that out if you're interested in working with Salesforce or talking more to Zineb or Renee. Another thing you can do is, if we go to the next slide, we are also having the slide of Trailhead DX. We're also going to be at Trailhead DX in San Francisco in late March. I kind of skipped past the couple of badges there, but we will share those after on Twitter. And so both Zineb and Renee will be there. I'm gonna throw them up on stage. They're gonna talk more about all those super fascinating questions that everybody has had on this call now. And they will also be standing around. So ideally, they'll be standing around at our developer forums or demo booths, where they're available to answer any questions you've got, and they can't run away. So
I'll just disappear.
They can't disappear. So if you have any extra burning questions that were not addressed in this call, keep an eye on buy a ticket, roll up, show up to San Francisco,
Track us down,
and you can chase them down in person. So with that in mind, thank you all again. We're going to close this call off because we're running up on time. Don't forget to answer the survey. We are really curious to see what everybody thinks. And thank you all again. See you all at the next webinar.
Have a wonderful day.
Thank you. Bye-bye.
Bye.